Hello and welcome back to the machine learning video series. We have started with the gradient descent model in the previous video, and I've seen something called learning rate, which defines how fast you are training your model. Also, now that we understand cost functions, little bit of gradient descent and how to minimize them, we come across an important question: when to stop training? Of course, the first thought is to train for as long as possible. This may not be the correct way for a number of reasons. Why? Let us look at an example. In the given plot, which hypothesis seems to perform better, the straight line or the polynomial? Even though the polynomial passes through all of the points in the dataset, a straight line appears to be a better fit because it gives a better idea of the general distribution of data. When presented with a new data point, the prediction with the straight line is more likely to be accurate than the polynomial. The polynomial is a good example of an overfit curve. The training cost with the polynomial is zero as it passes through all the data points. On the other hand, there is some training cost when we consider the line as our hypothesis. Hence, we can conclude that zero training error may not always give a good intuition of how well a model will perform on previously unseen data. If we keep training with limited data, our model starts to memorize the training samples and stops generalizing. This condition is called overfitting. The opposite of this is underfitting, when the model is not trained enough and it doesn't even perform well on the training data. In this case, the model is trained further so that the train accuracy improves. This is why it is important to divide the dataset beforehand into training and testing sets. If cost of an overfit model is calculated with test set, it comes out to be disproportionately higher than the training cost. This is an easy test to check the fitness of a model. The test accuracy and training accuracy together give a better intuition of model performance. Now you know what happens when someone does not optimize the training process. Now let's look a little deeper into the gradient descent model and how it actually works in the next video. Thank you.